session on triangles part 2. In this session, we will learn few theorems and understand the steps involved in the proof. So here is the first theorem, which states that angles opposite to equal sides of an isosceles triangle are equal. For that, let us take a triangle A, B, C. And according to the statement, we have AB equals to AC. This is given. And what is our RTP? That is, what are we required to prove in this? We need to prove that angle B equals to angle C. So for that, we need to do a construction. I take a line segment joining from A to D such that it divides angle A into two equal parts, that is, it bisects. Therefore, I get angle 1 as same as angle 2, that is equal. So this is based on our construction we got. Now we will compare triangle ABD and triangle ACD. In these two triangles, AB is equal to AC. This is given, and angle 1 equals to angle 2. This is based on construction, and if we see, AD is a common side for both. So we got three parts which can be compared in both the triangles, and so based on SAS congruency rule, I say that triangle ABD is congruent to triangle ACD. Therefore, whenever we have two triangles congruent, we can compare their corresponding parts, that is, sides or angles according to the need. So we can say that angle B equals to angle C. This is based on CPCD. So we got the required statement that angles opposite to equal sides of an isosceles triangle are equal. Now let's take the second theorem. So here is our second theorem, which states that the sides opposite to equal angles of a triangle are equal. So in the same way as we have done in theorem 1, let us take a triangle ABC. Here what is given? According to the statement, we have angle B equals to angle C. This is what given for us. And what are we supposed to prove? We need to prove that AB equals to AC. This is our RTP. So to get the required proof, as we have done in the first theorem, we have to do a construction, that is AD such that it bisects angle A. So I'll be getting angle 1 equals to angle 2. So this is based on our construction. Now I'll compare the two triangles ABD and triangle ACD. And I have angle B equals to angle C, angle 1 equals to angle 1 equals to angle 2, and AD is common. Therefore, according to AAS congruency rule, which we have studied in part 1, we can say that triangle ABD is congruent to triangle ACD. If the two triangles are congruent, we can say that AB equals to AC based on congruent parts of congruent triangles. Now let's see what is the third theorem statement. The third theorem states that in any triangle, the opposite side to the larger angle is larger. So for this, we will take a triangle. Consider that angle C is greater. So we have a triangle ABC where angle C is greater than angle D. And what are we supposed to prove here? We need to prove that side AB is greater than AC. This is our RTP. So for proceeding with the proof, we need to recall one theorem. And the statement says that if two sides of a triangle are unequal or unequal, the angle opposite to larger side is larger. Longer side is larger or larger side, it's any way you can represent. So based on this theorem, I assume for the proof that AC is greater than AB. Then angle B is greater than angle C, which contradicts our assumption. Hence, we can say that side AB is greater than AC. So some theorems need to be explained or proof can be given based on the other theorem. And now let's go to the fourth theorem. What's the statement of the fourth theorem? It states that the sum of any two sides of a triangle is greater than the third side. And for this, let us take a triangle and name it as ABC. And I need to extend the side AB such that AC is equal to ED. And what is given? We have a triangle ABC only. And what are we supposed to prove here? We need to prove that AB plus AC is greater than BC. So we have extended side AB such that AB is equal to AC. Hence we can see that angle 1 is equal to angle 2 because it forms an isosceles triangle. Now we will take angle BCD. Angle BCD, this angle is equal to angle BCA plus 1. This I'll take it as angle 1. This I'll take it as angle 1 and this I'll take it as angle 2. And which is also equal to angle BCA plus angle 2. So here I take it as angle 1 and which is greater than angle 2. But here, I mean according to the statement, we are approaching the resultant or needed proof. And similarly, now in triangle, we will compare BCD. Since the side opposite to larger angle is longer, we will take angle BCD is greater than angle 2. That means BD is greater than BC. That means AB plus AD is greater than BC. And we can see that AB plus AC is greater than BC. Similarly, AB plus BC is also greater than AC and AC plus BC is greater than AB. So this is how we proceed for the proof depending upon the statement, what is given and what are we supposed to prove, and check whether the construction is needed to proceed for the proof or no. I hope you have understood these 4 theorems and will be using in solving